Hi all, this is a quick video, shouldn't take more than 5 minutes to show you or help you find the equation of a line. Okay, so you all probably by now have seen the equation y equals mx plus c, and you should probably know what some of those things mean. Your x and your y are any point on the line, and that's dependent upon the constants in the equation m and c. Now m tells us what the gradient or the slope of the line is. We can calculate the slope of the line by looking at how far up it travels or how far across it travels. So that gives us the slope between the 2 points. The slope might go this way or it might go this way. I'm not going to go over the rest of those points there. You can look at them later. But basically the equation for that is m equals y1 minus y2, which is the two y coordinates of any points, divided by x1 minus x2, which are the x coordinates from any 2 points where we're working between. So once we find the gradient, we can then go on and find what the y-intercept is. So the y-intercept is where the line crosses the x or the vertical axis. So we've got a vertical axis where the line crosses, that point there gives us the point C in our equation. It's easy to work out what C is if we can see the graph and if the y-intercept is on the part of the graph that we're looking at. However, that's not always the case. It might not be an exact point, a number, or it might be a decimal point, or it might be way outside the scale of the graph that we're looking at. However, if we've got some points or part of the graph, we can calculate the y-intercept by substituting the points that we know into an equation where we already have calculated the slope. Now I've got another example here, but I'm not going to go over that. You can have a look at this slideshow worksheet in your own time. So let's have a look at this example. We've got 2 points here, the point 36 and the point 50. If we plot them on a graph, they'll look like this, 36 and 50. Then we can draw a straight line between those 2 points. And you can see here, it's sloping in this direction. We can see that it's got a slope, so it can go up and then across, so there's a slope. We can't actually see where it crosses the y-axis, but we'll show you that shortly. So let's calculate the slope. Here's our point 36. Let's give those points the 3, which is our x point. We'll call that x1, and our y point y1. Then we'll give our point 50 the coordinates x2 and y2. So we're going to substitute those into our equation y1 minus y2 divided by x1 minus x2. So m is equal to m is equal to 6 minus 0, so 6 is our y coordinate and 0, and we divide that by our y coordinates, 3 minus 5. So what we end up with is 6 minus 0, which is 6, divided by 3 minus 5, which is minus 2. So that gives us an overall slope of minus 3. So the slope of our line is minus 3. And we can see that here on our graph because we go up 6 points. So between 0 and 6, so this is 0 and this is 6, we go up 6 and we go across 2. So between 5 and 3 is 2. Now we can see that this, because we're going up, it's plus, and if we go left, it's minus. If the point was over here, we would go plus. But down is negative and left is negative. Up is positive and right is positive. We'll look at that some more examples later. So once we've got that, we can then calculate where it would cross the y-intercept. So we know the slope of our line is minus 3. So to calculate the y-intercept, we put that minus 3 into our equation in the place of the m. So now our equation is y equals minus 3x plus c. So then we substitute one of the points. Now it doesn't matter which point, whether it was 3, 6 or 50, both will give us exactly the same answer. So let's take the point 50. We substitute the 5 in for the x and the 0 in for the y. And then we're using the equation y equals minus 3x plus 3, and this is what we get here. Then we solve that equation by subtracting 15 from both sides, and then we have C equals 15 or 15 equals C. So now we know that our y-intercept is 15. So that gives us the equation y equals minus 3x plus 5. And that will be true for both of those points, or for any point on that line. So now that's the equation for the line. Now here's an easier example. This is an example where we can see straight away the y-axis. So this travels through 2 points, the point 0, minus 1, and the point 1, 2. So we can see straight away that it crosses the y-axis here at minus 1. So all we need to do is now calculate the slope of that line. So we do the same as we did before. We use the points 1, 2, and 0, minus 1, and we substitute that into our equation. Here's our equation. We put in the 2 minus, now here it's minus 1, so we make sure it's minus 1. So when we do 2 minus minus 1, that gives us 3, and 1 minus 0, which gives us 1. 3 divided by 1 is 3. So our slope of our line is 3. So we can now get our equation 3, which is our slope, plus minus 1, because we know that our y-intercept is minus 1, or we can simplify that plus minus to minus 1. And that's how we calculate the slope of graphs. The equation of our graphs using the slope and the y-intercept. The only other thing you need to worry about at the moment is looking at whether the slope is positive or negative, just to check that you've got those positives and negatives correct. Now in this case, because the plus 3 is going this way, so our rise goes up 3 and across plus 1, it's 3 over 1, so it's positive, and our slope goes this way. In the first example, our line went up 3 and back 1, and so that was in the negative direction, so that gives us a negative slope.